Hey everyone, welcome to my channel. In this video, we are going to create this amazing spoofing detector which will detect whether the person is present in real time or whether it's just an image or it's a fake. So it also works on images as well, which are printed. And as you can see, it shows me that I am real, I'm moving around. If I use any other image, you can see it also tells that if it's fake or not. And we can also try it with television to actually see whether it is detected as real or fake, because that is a screen as well. Now, how did we do this? We collected our own. That's the best part about this project, that we collected our own data sets in just 20 minutes. So we wrote a script that automates the detection process and the labeling process. And then using that, we trained our own model. And then within a few hours, we had this model running. So you can train it online and you can train it offline on your PC as well. And it works on phones, tablets, and it can detect multiple faces at the same time as well. So this is a very simple project to make, and it is very sturdy. So if you see here, you can see it's real and fake. It detects very easily. And what you can do is you can keep training your data as well. You can keep adding to this. So I used around 7,000 images to train this, and it works already quite well. But if you wanted more accuracy, if you wanted the best results, then the best thing is that you train it in your own environment. So if you are using generic data set with a generic model, then it's not the best thing to do. If you wanted to use it in real world applications, then the best thing is to use your own data set in your own environment. So imagine if you are detecting, for example, a hard hat and a helmet and maybe a jacket, then having your own employees wear it and collecting the data and training it is much better than having some generic model. So the same way, you can have it in your own environment. Face detection is a very big field, and face recognition, you have to make sure the real person is present, and this technique will definitely allow you to do that. And you can see it's super fast. You can see the frame rate there as well. It's around 32 frames per second, and it works really well. So we will go step by step, line by line, and we will write the script to actually split the data, to get the data, and I will tell you every single line why I wrote it and how I wrote it. If you would like to level up your computer vision skills, do check out our premium courses that are available on our CV Zone platform. Links are in the description. So without further ado, let's get started. So let's go ahead and discuss what exactly are we building today. So the idea is to create an anti-spoofing device for face recognition. So nowadays, a lot of the systems, they are moving towards face recognition, and whether it be attendance in a school or whether it be in an office, then you might need to take attendance with your face rather than biometric with your thumb. Now, it does save some time and it has a lot more benefits, like you can have multiple faces being detected at the same time and so on. So I'm not going to go into that much detail of why this is important. I'm pretty sure it's obvious why this is good and why this can be useful. The main idea of today's project is to learn how to collect the data and how to train it for your own custom data. Now, a lot of the times what people do is they go online and they get whatever data they want and they try to deploy it for their own custom application. Now, that is okay in a sense, but when it comes to real world applications, then that is not a very good idea. So our aim today is to learn how to deploy it in the real world. So we have created a lot of applications that are not really applicable to the real world. But now what we want to do is we want to create something that we can actually use. And because of this, we have already created the world's first web development course using computer vision, which allows you to create these exciting and amazing projects and deploy it in real time and in real world applications. So we are going to take a hint of that today. And what we will do is we are going to train our own custom data set, and then we are going to deploy it and see how well it performs. Now, whenever you want to deploy a model, what you should do is you should collect your own data. So today, the main idea will be how exactly can we collect data for this anti-spoofing device. So our main script will be collecting of the data. So normally if you collect the data, for example, let's say we wanted to take 5,000 images and then you have to annotate them, then it takes a while. For example, in another project, I annotated almost 500 images and it took me about 2 hours to do that. Now, if you have 5,000 or if you have 10,000 or 50,000, then that will take a long, long time. Now, the good thing in this project is that we already have face detectors. So what we need to do is we need to get those faces and then we need to create some sort of classification where it is fake or real. So instead of having two different, one as a detector and another model as a classifier, what we will do is we will combine them into one. And the best and the main part will be collecting of the data, and we will do it automatically, and it will take only 20 minutes. So collecting and annotating the data will only take 20 minutes, and it will include taking it from your mobile phone when you are actually displaying. It will also include real images from the webcam. Then we can also take it from, for example, an album so that we can replicate some paper being detected. We can also try it with a television where a lot of different videos will play and there will be a lot of different data sets of a lot of different people. So we'll be able to collect lots of data within just 20 minutes. So how exactly can you do that? So we have to write the code step by step, and the idea is that I want to explain every single line of this code so that if you have any other project that might have a hint of this, or it might be useful to you later on in your different projects. So that is my main aim today. So you will learn lots of different techniques. You will learn automation techniques. For example, we will split our data by ourselves and we will write a small script for that. And how exactly do we do that? How do we create directories? So you can simply press one button and within 3-4 seconds, it will split thousands of data for you. And all of this we are going to learn today. And then at the end, of course, we are going to deploy our model and see how well it performs in the real world. So let's go ahead and start our project. So what we have here is our PyCharm, and we have created a project by the name anti-spoofing. We'll go to its file settings. So the first thing we are doing is we are installing all the packages. So we'll go to Python interpreter, and here we are going to add CV zone. Then we are going to add ultralytics, and then because we are using Yolo version 8, we will have our own data set, and then we are going to train it. So we will be using ultralytics for that. And then we also need media pipe. Okay, so now everything is installed, and what we can do is we can test it out by writing import CV zone, then import ultralytics, and we can also import CV2. So we can see that all of them are being imported properly and we don't have any issues. We can run it and we don't get any errors. So that's good. So what we are going to do is we are going to create different scripts just for testing purposes. Whenever you are creating a new project and you're not sure of the direction, this is a good way to start as well. What you want to do is you want to create a new folder, and here you are going to write testing scripts. So inside this, we are going to add any testing scripts that we would want. So the first testing script that we want is for our face detector. So to actually collect our data, we are going to use a face detector, and using that face detector, we will get the regions of it, where exactly is the bounding box, and based on that, we will create our labeled data. So here we are going to write face detector test. Now the face detector we are using is provided by MediaPipe, which is provided by Google. So it's very simple. You have to write cvzone.imports face detection module, and we are going to import the face detector. Now, how exactly can we use this face detector? You can find it very easily. All you have to do is you have to press the control button and then you have to left click, and it will take you to the actual script or the actual module where this class is written. So here is our class face detector, and if we go down here in the main, this is how it actually runs. So we can copy all of that and we can simply paste it here. So then it says that CV2 is not imported, so we are going to import CV2. It is using video capture device number 0. I have multiple cameras installed, So I'm using 1. And then we have while true and all of that, and it is being detected. And then it is also being displayed with a center. Okay, so let's go ahead and run this and see if it works. So there we have it. Now we are detecting our face. I can move around up and down. There you go. And it's pretty good. So the next thing we are going to test is our Yolo. So we are going to write here, create new Python file, Yolo test. So to test Yolo, we are going to go ahead and copy paste the code for testing Yolo. And now you might be wondering what just happened? Where did you get the code? So I have a complete tutorial on Yolo version 8. You can see it on YouTube, and it's free. I believe it's 4 hours or something, and you will get all the details there. But if you want to just get this part, then of course you can go onto our website and you will find all the files to download from there. All you have to do is you have to register on the website and you will get the access to this for free. So now that we have the script, it is using a video. So we have to change that. We will comment this out. And here we are going to use video capture number 1 because I have multiple devices, as I mentioned earlier. And we are using 1280 by 720. Let's use 640. This is the resolution that we are going to use later on as well. So let's go ahead and do that. Now, what this will do is it will download the YOLO weights into this folder. So we don't want that. What we want is to go back. Yes, we want that, but store it in a new folder called models. So we will store all the models there. So let's download the Nano because it's a little bit smaller. Actually, it's not a little smaller, it's a lot smaller. It's around 6 MBs. So let's go ahead and run this. So hopefully it is going to download first the YOLO model, and it will store it in the folder models. And then once it is stored, it is going to go ahead and open up our webcam and then display us with the results. So let's go ahead and try that out. There you go. Now it's working, and if I move around, you can see it is dissecting person, chair, blah blah blah. And let's bring in my phone. There you go. We have a remote as a phone. We have cell phone, and there you go. So that is working well, and it is all good. Now if you wanted to run this using GPU, then you have to install the GPU version. So what you will do is you will write PyTorch start locally on Google, and this will give you start locally PyTorch. You will click on that, and here it will give you the option to start locally. We are using the stable version, and for Windows, then pip install, and then we are using Python, and we are using CUDA 11.7. So this will be the code. We will copy that, and then we are going to go back. And here, before we start, we have to uninstall. We have to go to settings, and here we have to go ahead and uninstall Torch Vision, and Torch Audio. Where is Torch Audio? So there is no Torch Audio, but if you had it, you have to uninstall it. So let's go ahead and uninstall this. So now if you run it, it will not actually work. There you go. Then you have to go to terminal. And in terminal, now this is very important. Right now it's not in your virtual environment, it's in the global environment. So you have to make sure you go to add, you have to click on the arrow, and then you have to click on command prompt. So here you will see it says virtual environment, and there is where we are installing this package. So we will paste it here and we will download. So it will install Torch Vision, and Torch Audio. And this is around 2 GBs to download, and it will take a while to download and install. So I had already downloaded this. That's why it is using the cached version, and it will be able to install it very quickly. Otherwise, it will take a while to download the 2 GBs, 2.3 GBs, the wheel. Okay, so now that the installation is complete, what we can do is we can go ahead and try it again. And this time around, we will get a much better frame rate. We will be able to see a significant improvement in the results. So let's try that out. There you go. Now it's running, and as you can see, it's much faster than before. So if you look here, the frame rate is around 30, 20, 30, something like that. And earlier we were getting around 10 frames per second. So it's 3 times faster, which is amazing for us. Okay, so and one more thing, if you're like me and you don't like these red warnings, then what you can do is you can go here in the model and you can write verbos equals false, and then it should not display these warning. It will only display us the frame rate. There you go. So now we have our frame rate being displayed, and I can move around and you can see it works well. So one more thing we need to test is how to create a file. So we are going to go ahead and create a new file, and here we are going to write text file test. So I forgot to write .py in front of it. So we can go ahead and open it up in Explorer. Over here, we can rename it to .py and it should convert. So we can open that up. And now what we need to do is we need to understand how exactly can we create a file. So to create a file, all we have to do is we have to write f equals open. So f basically stands for file. So file open, and what we are giving in is the name of the file that we want to open. So we will write here test.txt. And now comes the part where you have to give in the flag. What exactly do you want to do? So what we will use is we will use append. Now what this will do is if the file is not present, it is going to go ahead and create it. And if the file is already present, it will add the data to it. It will not remove the previous one. It will keep adding to it. So this is a very important part that we want later on as well. So we have to use that. So then we have to write f.write, and whatever you want to write, you can write inside. So we can say this is a new line, and then we can give in the new line parameter so that it goes to the next line if we are writing it again. And then we can simply write f.close. So this is how you can create a file. So if we right click and run it, there you go. We have a test.txt. This is a new line. And if we go back and run it again, then it will add another line to it. If we run it again, it will add another one, and so on. So it is appending, and if the file is not there, it is going to create. So we don't want any random errors. Okay, I did not find the directory and blah, blah, blah. Come on, it's 2023. Go ahead and create the directory if it's not there. It's so simple. Anyways, so these are the things, these are the testing files that we wanted to test or we wanted to create before we go on to our main code. So now we are going to go ahead and start writing our main code, which is basically creating or getting the data. So we will write here data collection. So this is our file, and what we will do is we'll go to the testing scripts. The testing scripts are there to make our life easier. So we will go to the face detector, and we are going to copy all of that, and we are going to paste it in our data collection. So what I like to do is I like to run it once just to make sure that everything is working. Even if I copied something that was completely working fine, I still like to go ahead and test it. And there you go. So we are getting our image, and we are detecting the face. Now, what we need to do is, first of all, we have to find this face. And as I can see, the area of the face is not enough. It's not covering my hair. And I believe it can be a little bit wider as well. So we are going to give a little bit of an offset so that it is covering the whole face. And even if it's covering a little bit of the back, then it's fine. It will help the model actually train better to know the environment as well as along with the face as well. So that's the first thing we have to do. We have to make this a little bit bigger so that it is easier to train the model. Then the second thing we have to do is we have to check for blurriness. Now, what exactly is blurriness? Now, if I'm moving my webcam, so when I will be collecting the data, for example, if we are collecting it for live people, we might keep it on one place and move around. That's fine. But if we are having it handheld and we are moving it around and we are collecting the data, especially for the fake ones, then it will be very shaky. The camera movements, so if I do this, you can see there is blurriness. So how can we remove that? we can remove that by checking the blurriness of the image. And instead of the whole image, we will check only the blurriness of the face. Because if the image is in focus over here and it's blurry over here, it might say, okay, it's 70% focused. So we don't want that. What we want is the focus on the face. So if it is focused on the face, then we will collect the data. We will collect a little bit blurriness, that's fine, because every now and then you will get blurriness from the webcam when you have movement, but we don't want to collect too much. So we need to do the blurriness as well. And then of course we need to give a threshold that if you are detecting a face, let's say if it's 50% sure, don't get that. Get at least 70, 80, 90% sure that it's a face, so that we are getting some good data rather than some weird images. And then once we have that, then what we can do is we can store all of that information, and then we can output it into a test folder. And in that folder, we will save all the data. And that data has to be in the format of Yolo. And Yolo format is basically having an image and a text file. And in the text file, you have the class name and you have the XY and the width and height. So you have to add all that information. That's why we learned how exactly can we create a text file as well. So that is exactly what we are going to do. So let's start with the first one, which is the increasing of our area for this rectangular box. Now, one thing here is that we can simply give it an offset. Okay, so I will say whatever you get, go 50 above that, 50 pixels or 100 pixels. But that's not a good idea, because if I go back, my face becomes smaller and the 50 will be really big. And if I come closer, then my face will get bigger and the 50 will be smaller. And if I go back, the 50 will be bigger. So we don't want that. We want a ratio instead. So what we will do is we will find the width. Oh, which hand? Okay. We will find the width of our image. And based on that width, we are going to add an offset in the width. And we will find the height of our image. And based on the height, we will add a ratio of that. And as you can see, at the bottom, it's pretty much getting my face already. So we will add a little bit offset, very small. But at the top, we need the big offset. So again, we will have different ratios for different scenarios. So let's go ahead and start working on that. Now, what we will do is we will remove this part, if bounding boxes, or do we need it? Yeah, we need it. So we will remove this. We don't need the circle. And here we are creating a bounding box only for the first face that is detected, which is not a good idea. But anyway, so what we will do is we need this part to understand what exactly are we getting. So here, what we will do, we will say if bounding boxes, then we will say for box, not box, bounding box in bounding boxes, we are going to loop through all the boxes. And then what we need are the X, Y, width and height values. So we will write here that our X, Y, width and height, they are basically bounding box. And inside that, it's basically a dictionary. So we have to give in this value. So it will be, bounding box. There you go. So now it will give us the bounding box information. So let's go ahead and print it out. We will print out X, Y, width, and height. Why is there a problem in indentation? Let's go back. Okay, now it's fine. There you go. We are getting the X, Y, and the width and the height. So that's good. So now what we need to do is we need to add, as I mentioned before, we need to add a percentage. So here we are going to define some parameters, and these will be the parameters which you might want to change based on your requirement. So we will put it here, we will highlight it. Okay, these are the parameters you have to take care of. So the first one will be our offset percentage for the width, and we will give it 10%, and the offset percentage of the height, and we will give that 20%. So how exactly can we integrate this? So what we will do is we will say that to the x position, we are going to, so x is basically the starting, the minimum point. So if this is our bounding box and this is x, we need to subtract the value from it. So we will subtract the offset. But before we do that, we need to actually find the offset, because this is a percentage of our width, basically. So here we will write our offset of width is basically our percentage, offset percentage of width divided by 100, and we will, it is 10%. So divided by 100, and then we will multiply it with our current width. So that will give us the 10% that we actually want to offset. So here we will say x minus offset w. Okay, so this will push it a little bit backwards. And then for our width, it will become width plus offset width multiplied by 2, because we will have it on the left and we will have it on the right. So offset left, offset right, and it will increase twice. So let's go ahead and try that out. So we have increased it 10%. So what we can do is we can put a rectangle, and we can test if it's working properly or not. cv2 dot rectangle, and we will give in our image, and then we will give in the rectangle. So this will be the x, y, and the width and the height, and then we will give in the color. So the color we are going to change, that's how we will know what it is giving us as the output. And the thickness, let's make it 3. So let's go ahead and run this. So there you go. The blue is basically, why is it not displaying us our actual rectangle? Oh, it is exactly overlaying on top of that, I believe. So did it not have any effects? So WW, okay, let's remove that and try it again. Were we drawing the rectangle ourselves, or let's find out. Okay, it is drawing, and I believe it's not the correct value. So the x is basically x minus offset, and the offset percentage is 10, which is divided by 100. Oh, single divide, my bad. That's why it's not doing anything. And we need to open this up to actually view it. So let's go ahead and run that. Okay, now we have a problem. Bad argument in the function rectangle. So what exactly is happening here? It might be that it's not. Oh, yes. It might be that it is not an integer. It's a floating value. So we have to make sure that these are integers. Whatever you have, just remove the floating points. So let's try it out again. And there we have it. So now you can see the width has been increased 10%, and now it is looking much better. So now we will do the same thing for the height. So this is for the width. Now we will do the same thing for the height. So this is offset height, offset percentage height divided by 100 multiplied by height, offset height, and this will be for y, and this one will be for h. This one will be for h. This one will be for height. Now, this will be y, by the way. So as I mentioned before, our y at the top, we need a lot more than what we need at the bottom. So the total height, we are going to increase. We are going to look at what exactly that will be. But for the top, for now, the offset, what we have to do is we will multiply this by 3. So a little bit is not enough. What we need is a lot. So here we will multiply this by 3. So let's run that and see what happens. There you go. So now the bottom is fine, but as you can see, now it's covering my complete face. So what we can do is we can try it out with other faces as well. Well, it's my face as well, so still my face, but as you can see, it is now covering the top part as well. Let me find any other picture so that we can test out. So here we have our image, and there you go. Now it's covering the head part as well. So we don't want to go too high, but as you can see, it is covering the part and it looks pretty good. So now we will add a little bit below as well because it's right at the bottom. So what we can do is we just need to change the height a little bit. So we will add 0.5 here. So, and that should bring it a little bit down. There you go. So now you can see the image, what we have now is much better than what they had earlier with this bounding box region. So if I move around, it is the same. Let me test with the other image that I have. There you go. It's much better. And let me test with the picture of my niece. There you go. So now it's much better and it is giving an overview of the face as well rather than just congested space over here. So this is our image. So the bounding box information is ready now. But what we have to do is when we are sending it for the labeling of Yolo versions, we do have to normalize these values. So we are going to look at normalization later on. But for now, what we need is the blurriness. We need to find whether our face is blurry or not. So let's go ahead and do that. So what we can do is, first of all, we can add some comments, some sections so that it's easier for us to know what we are doing. So let's write down here that this is basically for adding an offset to the face detected. There you go. Offset. There you go. And then what we will do is we are going to find the blurriness in the face. Find blurriness. So now we will find the blurriness. To find the blurriness, we actually first need the face. So we will crop our face here and we will write image face equals, we will get the image, and here first of all we have to give in the starting value, which will be our y, and then the ending value of the y, which will be our y plus height, and then the second value will be x, and then the other value will be x plus width, the ending value. So we are giving the range in which we have to find. And then what we can do is we can write cv2.imshow, and we can give it the name face, and then we are going to write here image face. So this is just for the demo purposing of checking whether it's working or not, whether we are getting the region correctly or not. Otherwise, when we are actually deploying it, we don't need that. So there you go. So if you look here, now we are actually getting the face. And as you can see, if I move around a little bit fast, you can see there's a little bit of blurriness that adds on to the face. Okay, so now that we have this, we need to find the actual value of the blurriness so that we can know whether to detect this or classify this as blurred or not. So we will write here that our blur value is equal to cv2.Laplacian, and then we will give in the image face. Then we have to give in the depth. So we will write here cv2.cv underscore 64 floating points. Then we will convert it into a var, and that should give us our value. So what we can do is we can actually display this value. So to display it, what we can do is we can display it next to our bounding box. Right now we are displaying using this. So let's remove that. We will write here that our display, or is it draw is false, and now it will not draw anything unless we tell it to draw. So here we are already drawing a rectangle, so here we can write this area is for drawing. So what we will draw here is the text. So we will write here CV zone because it will make it easier for us to put some text, because it will center the text, it will create a rectangle, it will put the text on it, it will center it and all that in CV zone. So we don't have to worry about that. So then we will write image and then the position, the text. So the text, what we need is the blurriness value. So here we can write an F string so that if we wanted, we can add more things to it. So here we will write the blur value, and here we can just write blur is this. And then we have to give in the position. So the position should be, where should we put it? We should put it at X and then at Y, but then it will go down. So we want it to push a little bit higher. So we can write minus, let's say 20, and we want to start by X. Yeah, we want to start by X. So let's run that and see if we get our blurriness value. So there you go, we are getting our blurriness value, but the value is, we need to convert this into an integer because we don't want that many floating points. So if I move around, you can see the blurriness changes, and it is actually going to 30s, something like that. I move around a lot, then it goes down. But if it is focused, then it is maybe 200, 300, and it can go up to 1,000 as well when it is really focused. So now what we can do is we can give a value that, okay, we need at least 20 or 30% of blurriness. If it's above that, then only we are going to save the values or save the files. So that's the idea. And one more thing here, what we can see is that if, let's say, if I open this up and if I move to the side, there you go, it will give an error. So what exactly is happening here is that our value, it is going below 0. So it is giving us a negative value for the bounding box. So that's why it is giving an error. So we cannot have that. So we are going to add a failsafe here, and we are going to add it over here, and we will write to avoid values below 0. So all you have to do is you have to write if x is less than 0, then x equals 0. Now you could also do using minimum maximum, but you can do it like this as well. So here we have for x, then we have for y, then we have for width, and then we have for height. So now if I move to the side, it will remain on the side. Yeah, there you go. So it will not go further. So that's the idea. But here, as you can see, if I move around, even the dragon is being detected as a face. So we don't want that. We want a confidence value, a good confidence value. So for that, what we will do is we will check what is the score. And if the score is good, then we will go ahead to our detection part. So check the score, and here we will write, first of all, we have to get the score. So here, like we did here, we are going to write here score, and we will write here score as well. So this is how you get the score, and you can write here if score is greater than our let's say confidence, then only we are going to go ahead and do all of this. Oh, I pressed the wrong button. There you go. So now it's saying, wait, what happened? Where is the confidence? There's no confidence. Don't worry, we are going to put a confidence. So this value we are not really going to change. I believe it's a good value. Then so this confidence value also, once we set it, we're not going to change. especially when you download it, and if you want to use it for yourself, then you might not want to change these values. It should be fine, but there will be some values that you might want to change, like the directory and the paths and all that. Okay, so we are getting an error that this operator is not supported because this is not actually a floating value. So we have to write here float, and that should be good. So let's run that. Still we have a problem. Argument string real number. Okay, wait, maybe it's not that. Wait, what happened here? Let's try to find out. Print score. Interesting. I thought it might not be floating value. It is a floating value. Oh, there's a bracket here. Okay, so all you have to do is you have to put a 0 here, and that should be fine. Okay, so now it will check only if the detection is above 80%, then it will detect it as an object or as a face. There you go. So there you go. Now if I move, there you go, the dragon is not being detected as a person because it should not be detected as a person. Because the confidence level. Okay, so that is good. Now what we have to do is we have to normalize these values. So we have these faces and we have the location of them as well, but Yolo needs a specific version of the file. So what it does is it normalizes these values. So here we are going to write normalize values. So what is normalization? It's basically putting the values between 0 and 1. That's it. So, and it is based on a ratio. So the ratio of the x will be based on the width, and the ratio of the height will be based, the y will be based on height, so of the image. So what we can do is we can get, first of all, the image height and the width. Now we already have that in cam. Did we save it in cam? No, we didn't. Okay, we should. So here we should write cam width and cam height equals let's say 640 by 480. So, and then we will put here cap.set, and number 3 is the width. So we will write here cam width, and number 4 is the height. So we will write here cam height. So we already have these parameters, but we are not going to use this because sometimes the camera actually does not support what you write here. So it might have its own image size. So in that case, everything will go wrong and you will not know that something went wrong. So image height and then image width. So this means the bigger image, the main image height and width, not of the face. And then the channel, we don't care about the channel, so we write underscore, and then here we will write that our image dot shape. Okay, so now we have these values. Now all we have to do is we have to get the normalized value. So what we will do is we will write here that our x normalized equals whatever value we have. So right now we have the value of x. So here we will write x divided by the value of IW. So that's how you can find the normalized value. But here's a twist. The twist is that they don't actually want the x and y values. They want the center point. So they want the middle values, xc and yc. So first of all, we have to go ahead and find those. So here we can write that our xc and our yc equal, so xc will be x plus, because our starting point is here, it's 0 0, and then the middle point is somewhere here. So we are going forward half of the width. So if this is the full width, then we are going half of the width. So we will write here the width of the image divided by 2. So that will give us the center position, and the same way we are going to do for y. So we will write here y plus the height divided by 2. So this will give us the center points. So let's go ahead and print those and see if they seem correct. So there we have it. So this is the center point and this is the center point. So the x and the y. So later on, when we normalize the values and we come back, we are going to check whether we are getting the correct values or not, just to make sure that we are headed in the right direction. So now what we will do is we are going to get the normalized value of the xc and yc rather than just x. So we will write here xcn, the center point normalized value, and here instead of x we are going to write xc. Now once we divide it here, what it will do is it will give us a very long value, 0.5389811 blah blah blah. But what we want is up to 6 floating points. So what we will write here, that we want to round it up till 6 points, and this value we can define up as well. Over here we can write here floating point equals 6, and instead of giving that we can write here floating point. So there you go. So the same way we are going to get our y, so we can write in front of that. There you go. So we have for y, and we can copy this part and we can paste it here, and this is for yc, and this is ih, and the floating point is the same. So this will give us the points. So what we can do is we can check here that xcn and ycn. There you go. So let's see if it is actually giving us. So where is the print? Let's remove the print. We don't want that here, and then we will only print this part. So right now it should give us a floating value with 6 decimal points. So there we have it. So now it's giving us the normalized value with the correct decimal points. So that's good. Now we can close this, and just to make sure, this is x and this is width, and this is y and this is height. So don't make that mistake. And then we have to do the same thing for the width and the height. So the width and the height, we don't want any center or anything for that, so we will just write it like that. And here that should be width normalized, height normalized, is basically your width divided by IW, and the same thing is basically here. So we can simply copy that and we can paste it here, and instead of xc we will write w, and instead of yc we will write h. So that will give you the normalized values. So what we can do is we can copy that as well, and then here we are going to paste it. So let's run that and see if it works fine. So there you go. So now you can see we are getting our normalized values and the width and the height. And now you might face a problem, and let me show you that problem, and you will realize it once you have all the data set and you are already in the training part, and then it will give you an warning or an error saying that okay, some of your data is corrupt, and that's the reason why. So here we are going to fix that. So what happens is that if I move around and oh, there you go. So I'm trying to replicate that situation, but I'm not getting there. The idea is that the values might go above 1. So if the x and y, or somehow these values, they can go above 1. So we don't want that. So what we will do is we are going to go ahead and make sure, like we did here, to avoid values below 0. Here we are going to write to avoid values above 1. There you go. So here we are going to give in the xcn, then we are going to give in ycn, then the wn, and the hn. If the value is greater, 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 then the value of 1, 1, 1, 1, then here we will write 1, 1, 1, 1. So what this will do is it will avoid having values above 1, so it will not give us corrupt data, and this will make sure that the values are not below 0, so they are not negative values, and that will also help us to avoid corrupt data. So that is basically pretty good. So far we have the text for our normalized value, and we are ready to actually save the image and save the text as well. But before we do that, let's just put another rectangle, or let's just put the information here. So we will add the information of the score, and the score is basically score over here, score multiplied by 100, and we are going to make it an integer so it looks good, and we will also write a percentage in front of it. There you go. And then we will make sure that the text is small. So here we are going to give in the scale. Let's say it's 1. Hopefully that's a small scale. So let's run that and see if everything is working fine. Then we can finally move on to saving part, and then we can start collecting our data, and we will see how exactly can we do that. So there we have it. There you go. Score O. The values are good, but the thickness is not good. So the thickness, let's make it 2 rather than, maybe it was 4, 5. There you go. So now it's much better. Maybe we can put the scale to 2 and the thickness to 3. Let's try that out. So I like to make it appealing as well, not just the backend is working, but it should look good as well. So that's why I go through the process of doing all that. And we can make it 15 as well if you want to touch this blue region. So yeah, now it looks good. Score is 96%, 95%. Blurriness is this. If I move around, the blurriness actually increases, so the value reduces. So that's good. And now what we can do is we can finally move on to the saving part, which is the main part where we are collecting our data. So what we will do is, after our loop, once the bounding box has done everything and we have all the information, then only we are going to go and check for the save. So we don't want to do it in between this loop because it is going to every phase. So we want it to complete all the phases and then do it. So we will only do if there is a bounding box. So we have to do it in this line. No, not in this line, in this line. So inside this loop we have to do. Okay, so here we will write if save, then we will do all of that. Now what is save? Save is a parameter that we will add so that sometimes we just have to debug. We don't want to save again and again. So we can write here. So right now save is true. So it should save the files. Okay, so what exactly are we saving? Let's just write pass here so that it doesn't give an error. So here what we have to do now is we have to create 2 lists. So the first list that we will need is the list blur, and that will be empty. And we also need the list info, and that will be empty as well. So what exactly are these 2 lists doing? So this will contain true, false values indicating if the faces are blur or not. So let's say we have 3 faces detected. So it will have 3 values: true, false, true, for example, or true, 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 or false, false, true, something like that. So what we need to do is we need to save our values inside this. And then the list of info is basically the normalized values and the class name for the label text file. So this has all the information that we need to send to the text file. So again, it will have multiple of these if we have multiple faces. If we had just one face, then we don't have to create list. We can just do it within the loop. But because we have multiple, we are creating a list, and this list should be outside so that it resets every iteration. Otherwise, it will detect once, and next time if it's not detected, it will just use the previous values and it will be all wrong. So let's go ahead and do the blurriness first. So here we are finding the blurriness, and then we will say that if blur value is greater than the blur threshold, and now it's saying, wait, what? Where is the blur threshold? So we need to write here that here is the blur threshold, and we want to give in a good threshold value. So let's say 35, and we will write here larger is more focus. So now we will go down, and if that is the case, then we will write blur value, no, list blur dot append, and we will write the value of true. If that is not the case, we are going to write list blur dot append. What did I do here? False. So if the value is greater than the blur, it means it's not blurry, or it's a little bit blurry, then it will be true. If it's not, then it will be false. Okay, so that is good. And what we can do is here, if we go down here, and now we can go through the complete list, we will write if, or let me show you what do I mean. So print all blur list. Now what this will do is it will go through all the list, and it will check if all the values are true, then it will return a true. If all the values are false, then it will return a false. So if I have, for example, 5 images, 5 faces in the images, I want all of them to be focused, not blurry, and then I will save the image. Otherwise, if one is blurry, the other one is not blurry, then I don't want to save that because I want good, clean data. So that's how we will fix that. So if I save this now, and we can also print the list info, oh no, sorry, the blur list, yeah. So we will print the blur list, and we will also print the list blur. So right now you can see it shows true and true, and if I bring in 2 faces, there you go. So now it will show, if we go down, now it will show 2. There you go. So it will show true. Here you can see sometimes it's false. So then the output is false. So the output of this command is false. If both of them are true, we go up here, true, true, then it will give the output true. So that's the basic idea. We want it to be true. So we will write here if this is the case that we have true, and we also want to make sure that our list blur is not empty. So if it's empty, then we don't want to save images, right? It means nothing was detected, no face was detected. So if it's empty, then we are not going to do it. Then if it is, then we can go ahead and save. So when it comes to saving, we have to save 2 things. The first one is our face, the image, and the second one is the text file. So let's just write here. Let's just write here that this is to save. And here we will write if save, then we are going to go ahead and save our image. So here we will write save image. But how exactly can we save the image? So to save the image, we need a file name. So we can simply write cv2.imwrite, and then we need, let's say, count, and we can put an f string here. We can put it inside this. Let's say count, and then we can write here that we want to write our image. Okay, so that is good. But If we add a counter and every time we start again, then every time it will reset the counter starting from 0. So that is not a good idea. We want unique values, exactly unique values. So what can we do? We can get the unique values with time. So we can write here from time imports time. So time is going to give us unique values. We will ask it to give us the exact seconds right now, and it will give us the values, and those seconds will never be the same again. So that's why we will have a unique value. So here we can write print time, and that will be a very unique value. But there is a problem. Let's go ahead and run it, and I will share the problem with you. Let's remove that, and so that we don't have any other interference. So now you can see we have the seconds. So these are the exact seconds, but here we have a decimal point. And to be honest, I don't like to add decimal points to files. Now you could do that, but as I mentioned, I don't like to do that. So what you can do instead is you can remove it. So how can we remove it? It's actually fairly simple. What we will do is we will write here time now equals time. And then once we have the time, we are going to split it. So we will write here time now equals time now dot split, and we want to split it based on a dot. So now once you split it, it will give us two values in two different lists. So if we run that, oh, there is a problem here. Because float has no attribute split, because we need to convert this into a string, because string has the attribute of splitting. So let's run that again and see what it gives us. There you go. So now it's splitting it up into two portions, and it is putting it in a list. So this is value number 1 of the list, this is value number 2. So now what we can do is we can combine them. It's just two strings, so we can say time now equals time now at 0 plus time now at 1. So that's how you can remove the dot in between. So there you go. Now we have the value without any decimal points. So that is good. Now what we can do is we can put it here and save it. But the thing is, we don't want to save it right in our parent directory. So what we can do is we can ask the user, and this is the most important thing. This is the outputs folder path. And we can, for example, add here dataset slash data collect. So we are putting it in a folder datasets, and then inside that we have data collect. So let's use that here. We are going to create we are going to write here output folder path slash time now dot jpg. So this will be our image, and it will be saved here. So let's go ahead and run this. So right now save is true, and if we don't have a lot of blurriness, it is going to go ahead and save the data. So let's go ahead and see what happens. So let's open that up, and if I move around, nothing is happening because oh yeah, it's not creating the folder by itself. You have to create the folder. So here we will write data set, and then inside data set we are going to create a new directory by the name data collect. So let's run that, and now let me just open it up in the Explorer so we can see it in real time being saved. I will make this smaller, and there you go. So now you can see the images are being saved. If I move around, you can see the images are saved. But here, as you can see, it is drawing on the images themselves. So we don't want that. In the output image, we don't want to draw these, but we do want to see them. So in order to do that, what we can do is we can write here image out equals image dot copy, and instead of putting it on the actual image, we are going to display it on the image out. So in the drawing part, here is the drawing part, we will do it on the image out instead, image out. And when we are saving, we are going to save the image, not image out. And when we are displaying, we will display the image out. So this way it will not save them with the drawings. So let's go back to the Explorer and we will delete all of these. So there you go. So now it is saving without these parameters. Now let's add a functionality for debugging where you actually draw it on the image as well. So here we can copy this part, we can paste it. Did we write the score? Yes, we wrote the score as well. So here we will write if debug is true, then put it on the actual image as well. Sometimes you are not able to understand what exactly is happening, so you save the images with the labels and all that so that you understand what exactly are we getting in the output. So here we will write debug equals false. So again, you won't have to change this, so I will put this down. These are the values you might need to change. So now if it's debug, then it will put it on the image as well. So right now it is false, so let's make it true and see if it puts it on that as well or not. So let's open that up. So these are the old images without the bounding box information and the score information, but the new ones are going to have these because right now we are in debug mode and it will show us. So for example, this is very handy. It's very useful to find the good blurriness value. So here when I stop it, I can go and check, okay, at this point my blurriness was 114. At what point was my blurriness low? Here you go. So here the blurriness is 39. Now, do I want this? Do I don't want this? The score is 94%. So these are the things you have to decide. So what you can do is you can put the blurry threshold very low so that it gets everything. And then based on the images you get and based on the stored values, you can find, okay, this is a good blurriness, this is not a good blurriness, and so on. Okay, so that is done. Now we can delete all of this. Let's delete all of that. There's 500, almost 600 values saved. So here we are going to write false, and now our images are stored and they are good to go. But we need to store the label file. So how do we store the label file? So in order to store that, we have to write it down here. So we will save image, save label text file. So we will save the label text file here. So how can we do that? First of all, we have to store it. So once we have the values ready, so after the drawing, before the drawing, we can simply put it in info list. List info equals, or dot append, we are going to append the value. So the value we are simply going to send in a string. So let's write an f string, and here we are going to give in the class ID. So the first, so this is the format that Yolo requires. So that's what we are following now. So the class ID you have to set. So this is the most important thing when you are getting. So what we will do is we will put here that 0 is fake and 1 is real. So if you are collecting the data for fake, make sure it is 0. If you're collecting the data of 1, make sure it is 1. So you don't want to collect mix and match. You want to collect all the data for fake, and then you want to collect all the data for real. So don't mix them up. Okay, so then here the first one is the class ID. Then we need a space, and inside that then we need the XCN, the normalized value. Then we need another value, and that will be YCN. Then we need the WN, and then we need the HN. So this is the format in which Yolo requires it. And we also need to add a new line so that when we put it in our text file, it actually adds that new line. So it should be below. So let's save that. And now if we go down, if we open up our testing scripts, and inside that, if we open up our text file, we can simply copy this part and we can paste it here. And now what we have to do is we have to put in a loop. We will say that for info in info list info, go through all of them, and then we have to, now here the text file name needs to be similar to this. It should be exactly the same, except it should be .txt rather than .jpg. And then if it's not there, it will create a file. That's not a problem. Then what exactly are we sending? We are sending the info. That's it. That's how simple it is. So if we have multiple faces detected, then it will store it in multiple lines. So not multiple text files, same text file, multiple lines. That's why we cannot do it inside this loop. We have to do it outside the loop so that it doesn't create 2-3 files for 2-3 faces in the same image. So yeah, that's pretty much it. And if we run this now, and if we open up our data collect, now we should be able to see some files as well with the corresponding image names. So let's try that out. So there you go. Now you can see for each data we have the file as well. And if I bring in 2 faces, there you go. If the blurriness is good and it's detected well, then it will select that. So let's stop that and review what we have. So here in data collect, let's open up any of our images. So this is my image, and then corresponding value is this. This is the class ID, it's 0, and then this is the, so right now I'm just testing. So that's why I had the real image and the fake image. Otherwise, when you are collecting the data, then you want all fake images and all real images separately, not mix and match. So here we have got these images with dual faces, but here we are not actually getting 2 faces because the image is really blurry. So it's detecting one of the faces and the other, the detector is not detecting. So our fail safe is that if the detector is detecting the face and it's blurry, then it will not save it. So right now what's happening is that it is detecting one of those faces, and because it's so blurry, it's not detecting the other one, and then it's saving one of the faces. So that's a little bit difficult. So that's what I don't recommend, that you have 2 images very close to each other. So what I can do is, in order to replicate the same thing, I can have my phone and my real face. So I can try getting the data like that. So if I do this, there you go. Then I'm going to check it out. So let's see if that works. Let's wait for it to start. And there you go. So if I have this, now you can see the blurriness is good. And now we should have both the locations of both the faces. So if we go down, 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 and there you go. So if I open any one of these, now you will have 2 faces. So that's the main idea. So that's working well. Now, one more thing we have to do is now we have to check. We have to check if it's right or wrong. Because if we are detecting the wrong thing, then it will be very problematic for us. So what we will do is we will turn on the debugging. We'll collect some data and we will check one of them. So we will write here true and we will run it. And then using Paint, the software Paint, we are going to go and check the actual values. Are we actually getting the correct normalized values or not? So let's wait for it to run. There you go. So now it's collecting the data and it should save with the, yeah, it is saving with it. So we can stop it and we can put this as false. And here we are going to open this up, and any of these files, let's say the last one, we will open that up, and here we are going to open this file up. So how can you check it? I can right click and go to edit, and this will open up Paint. So here we are going to draw. So what does paint do that helps us is that when we put the cursor on the left hand side, you can see at the bottom left hand side, you will see over here, you get the X and Y positions. So we are going to check if these X and Y positions are correct or wrong. So we will open up a calculator. So here we are going to open this up. Now the first value we will copy and paste and multiply it by 640 because this is the width. So X value is what is it? 241. 241, and then our second value is 0.5, and 0.5 into 480 is 240. So it is again 240. Remember, this is with 480 because this is the Y value. Then we will copy this part. This is the width multiplied by 640 is 237, and then we have 0.7 into 0.7 into 480, that will give 336. So how can you check this now? So this should be the center points. So we will go to 240. So I will try my best to go to 240. Where are the colors? So let's go to 240 and 240. So let's go to 240 in the X first, 241, okay, and then 240 in the Y. There you go. So this now almost at this point, it's around 241 and 242. So this is the point. So does it look like center? Yes, it does. So it seems that we are headed in the right direction in terms of X and Y values. Then we will check for the width and the height. So here our value is for the width is 359, and here the value is 124. So 359 minus 124 equals to 235, and here we are getting the value of 237. So it is very close. It means it is correct. Then at the top we are getting the value of 58, and here we are getting 407. 407 minus 58 will give you 349, and here we are getting 336. So here I'm assuming the value, so that's why it's a little bit off, but the values seem correct. So there doesn't seem to be an issue with this. So that's good. Now we have tested as well that whatever we are collecting is actually the correct values. So we can go ahead and delete all of that. And this pretty much sums up our code for collecting the data. And now let's go ahead and collect some data, and I will share some examples of how you can do that. So now we will go ahead and look at how exactly can we collect the data. So the first one we will collect is for the real face, and we will put 1 here. Just make sure it is 1. Go through all of these, the ones that are within these comments that you might need to change some parameters. So class ID has to be 1 because we're collecting real faces. Then output folder is data collect, that's fine. Then confidence is 0.8, that's good. Save is true, we want to save it. Blur threshold is 35, it's fine. Debug is false, that is important. And the rest of them we didn't actually change. So now what we can do is we can open up our data sets, open Explorer, and here inside data sets we have data collect, but now we want to create a real folder, real, and then we want a fake folder. So in real we will add all the real images, in fake we will add all the fake images. Now the reason for this is that when we are collecting, we will collect pretty much everything we can get. Once we have that, then we are going to make sure that the ratio of fake and real is same. So if we have, for example, 5,000 images of real, then we should have 5,000 images of fake. So to keep the ratio same, we are putting it in different folders, and then we will create a new folder by the name all. So this is the folder in which we will have all the files from fake and real, so that we know how much data we have added. So in order to do this, now I will do a demo. We will collect only a few images, and in all we are going to add only a few images as well, but I will explain how can you get more data. So let's go ahead and run this, and we will open up data collect, and inside this we are going to have a look at what exactly are we getting. So what I can do is I can collect the images in a little bit different manner. So I can move around like this. I can, for example, change my glasses. I can look at the side here and there, and then I can also wear a hat or something like that. So let's stop that. And now we can see we have collected some data, and of course what you want is as many people as you can get. So bring in your family, bring in your friends, ask everyone to come in and move around, from the back, then from the front, from the sides, here and there. Change the glasses, put a hat on, different clothes, all that, and you can get a lot of data. So for example, just in a few seconds, we got 642 items, which means we have almost 300 plus images, 321 to be exact. So it's half of them. So here you can see we have the data. That's good. And now you can see if we open it up, we have the class ID 1, and these are the coordinates. So we will select all of these and we will cut and we will paste it in real. Now you don't want to have anything in your data collect. Data collect is only when you are running the script. That's it. Don't save anything there. That's why we have the real and fake folders. So let's say this is the real folder, and then we are going to go ahead and detect the fake ones. Now for the fake ones, don't put the camera in front of you. Put it on the side and make sure you are not in the camera and you are collecting it from the side so that it doesn't detect your face. Secondly, you can detect it from your phone. It's very easy. Just open up your gallery and keep scrolling, and you will find a lot of faces. I'm pretty sure you have a lot of images and you will get a lot of detections. And then the same thing, do it with a TV. And then the same thing, do it with images of paper. So let me show you how we can do for phone and TV. So let me just open up. So I will move on the side so that it doesn't detect me. And yeah, see, I forgot again. So make sure you don't do this mistake. You have to write here 0 because now we are collecting for fake. So let's run that. There you go. I am on the side. And now I can bring it in and there you go. So it is detecting. I can move around. I can go back and I can go into the front. Then I can go ahead and switch. I can change. So that's the best part. Right now it's not detecting. It's not getting any images because I have stopped. And then now it's collecting again. I can move around. There you go. Then I will detect again. There you go. So all of these are being saved in fake. And yeah, then I will add another image of myself. There you go. So that's how you can collect. And then I can hold the camera and I can block it so that it doesn't show anything. So then what I can do is I can get the fake images from a television. That's very simple. And what you can do is you can open up a news channel, and mostly over there they have focused images of which are similar to portraits. So you might want to use that for your collection of data. So let's go ahead and I will show you how exactly would that work. So here, for example, I have opened up a channel, a news channel. I can move around. We have different people. That's what I was mentioning, that when you are on a news channel, then you are getting different faces. And especially in these talk shows, it's very easy to find and detect these faces. There you go. And of course, TV ads, they are also a good source. So if there are any ads running around, you can see the faces, they change a lot. The environment changes, and there are different people. So you can collect the data, and all of this is going into the fake. So this is the basic idea of how you can collect. So now we can go to data collect, and here you can see we have all these images. So we have 2,300, which means we have almost 1,150 something files. So here you can see all of these are fake. So, and what you can do is you can visually go and check if you find something very repetitive, or if you find something that is not good, you can go ahead and remove. But for most of the part, it should be fine, and we should have some good data. For example, here it's a little bit blurry, but still it is workable. It is fine. And of course, you can go ahead and change the blurriness parameter, and that will help you with that as well. Okay, so now we have this. We will select all and cut it, and then we will go ahead to the fake and we will paste it. So there you go. Now all the files are here, and if we have multiple faces, it will detect with multiple. It will have within the file, it will have 2 faces here or 3 or whatever. So this is the idea of data collection. Once we have this, what we can do is we can go to real, and now we have 640 images, and here we have 642 files. So I will select all of these and I will cut it and I will put it in all, and then I will go to fake, and from here I'm going to select 642 images as well. Now what this will do is it will make sure that they are balanced. So 642 is what we need. Now again, this is only for demo purposes. Later on we will be using, or wait, I actually put a lot there. In real, let's bring all of them back. So let's bring them back. And what you want to do is, now for the testing purpose, I want you to do this as well. Just collect only 20 images. That's it. So 20 from here files, 20 files from here, and 20 files from fake. And I will tell you why. So the last one is the script. So make sure you get the text file as well. So 506 and 506. So I will cut this and I will paste it in all. So now I have 20 items, and then I will go to fake and I will select 20 items. So I want a little bit of diversity. So I will cut this. These are 4 and I need 16 more. So I will go here and I will select, let's say here and here. So this is 20, 17, and this is 16. So we'll cut this and we will paste it here. So now we have 40 items, which means we have 20 images, and 20 images means that we have 10 for fake and 10 for real. So that's the main idea. And the reason we have this is because right now we are going to go ahead and create a splitting script. Now, if you have a lot of data, first of all, it will take some time when you run it, when you are testing it. Secondly, when the figures are really big, you might not understand what is happening at the back end. So it will be much easier if we have small data set and we can manage and see how many files copied, how many didn't, and what is happening at the back end. So now we are going to go ahead and create our split file. So here we are going to go ahead and create split data. Now the thing is that when you want to split based on Yolo format. So in Yolo format, you have folders which are basically train, test, and validation. And inside each one of these, you have images and labels folder. Inside images, you will have all the images. Inside labels, you have all the labels. So that's how they want the format to be. And then you also have a data.yaml file. We are going to create that as well automatically. So everything will be automatic. All you have to do is press the run button and it will split it everything for us. So the first thing we will do, we will import all the libraries. We need import OS. Then we need import random, and then we need import the shell utilities. And then we need from creation tools, we need PySlice. So these are all the libraries that we want. I will explain what each one of them does. Okay, so the first thing we need is the output folder. So output folder path equals, and here we are going to give in the path. So it will be dataset / split data. So this is the folder name. So now what we have to do is we have to create this, and if it's already created, we have to delete it and then recreate it. And now you might be saying, wait, why do we have to delete and recreate? Because if you are let's say randomizing and you are collecting some images, and then next time you run it, it will collect some random images again and then add it to that. So add it to the folder. For example, in the test folder, if we had 2 images before and we run it again, it will become 4 images. Then we run it again, it will become 6 images. So we have to make sure we delete everything, and it will not take some time. It will be very, very fast. So we don't have to worry about that. So what we can do is we can write here try, and we will use the shell utility, and we will say remove tree. And you might be asking, wait, why are we using this instead of just using os.remove? Because in os we have .remove. The reason we are using is because os remove will only remove the directory if it's empty. This will remove the complete thing with all the files and everything. So we are going to write here output folder. If that is deleted, then we will write here print removed directory, and then we are going to write except any error, let's say os error as e, and then we are going to give in os dot make directory, and we are going to make the output folder path. So let's go ahead and run this and see if it works. So if we run this now, in the data sets, we don't have anything here. Oh, I think it's not running this, it's running data collection. So we need to run split data now. There you go. And now it created split data. So every time it will run, it will say removed directory, and then it will start over again. So now what we have to do is we have to create the folders. So directories to create, because we have a standard format of creating this. So that's why we are going to write that. Okay, how can you do that? We can write os dot make directory. Now what this will do is it will only make it if the parent directory is available. If the parent directory is not available, it will not create it. So instead, what we have to use is make directories. That's what we will use. And if the folder is not there, it will keep creating the folder until it reaches that point. So here we will write F, and here we will write the output folder path. After that, then we have some specific names. So for example, the first one we will have train, and then we have to create images. And we will say that if it's already created, if it's already there, then don't give us an error. Just move on with your life. Don't make trouble for us. Okay, let's not save that because it's removing these two right now. Anyways, so if we run that, now it will make this directory. So in split data, now it has train and images. So now we need to make for labels. And if we run that, now we have images and labels. So we can copy this and paste it 2 more times for the validation, and then for the test. So if we run this now you have test, train, images, labels, and all that. And they are being deleted and then created again every time, so that we don't repeat or we don't overlap with the data. Okay, now that the directories are done, the next step is to collect all the images name. So once we have the images name, we can randomize them, and then we can copy the images into these folders. So first of all, we are going to create the directories. Then we are going to shuffle. After creating directories, we are going to get the names. Then we are going to shuffle. Then we are going to find the number of images for each folder. Then we will split the list. and then we will copy the files. Okay, so let's go ahead and start with the getting of the names. So how can you get the names? You can simply write down list names equal os dot list directory, and we give in the input folder. So the input folder we have to define here, input folder path equals data set slash all. So let's run that. Why are we running? We need to paste this here, and then we can print list names. So let's run that. Okay, so now it removed the directory, and then here we have the list names. So here you can see that these are all the image name and the text names. So here we have, if you wanted to check, you can check how much data did we collect, and we can write here the length of this. There you go. So we have 40, so that is correct. But we actually have 20 images. The other ones, they are just corresponding text files. So what we need are the only names. So this and this, it's exactly the same name. So what we need to do is we need to get all this only one time rather than having two times. So this list should be 20 values, not 40 values. So how can we do that? So in order to do this, it's very simple. We can write here unique names equal empty, and we will say for name in list names, we are going to loop through all of them, and then we will write unique names dot append. What do we need? Earlier we used a split command. If you remember, we used a split command. So we will split the name into two parts using the dot like we did before. So we will say name dot split, and we will say use the dot to split it, and then it will split it into JPG and this value, and then we will say get the first value. That's it. So it will get the first value, and then we can print length of unique names. So we run that. Earlier it was 40 and now it's 40 again. What happened? Nothing. So let's just print it and see what exactly is happening. It's not actually unique names. How is it unique if it's repeating? So here we have removed the .jpg, but it's still the same. These two numbers are same. So how can we make them one? So we will say remove the repetitions. How can we do that? All we have to do is we have to write set, and then that's it. It will remove all the unique names. There you go. So now it's 506. The next one is also 506. Wait, what happened? Print sets. Oh yeah, it's 506, but the value before it's different. So yeah, I got confused as well. So what we can do is we can save it. So we will write it down like this: unique names equals list, because we want to convert it back to list. That's why we are writing it like this. Then set, and then unique names. So now if we check the length of unique names, it should be 20. There you go. So now it has removed all the duplicates, and now it has saved it into the unique names. So that's good. So the next step is to shuffle it, because we don't want, for example, if we have taken images, actually let me just show you. So if we go to, let's say, real, and we open it up, or let's go to fake, open up Explorer in fake. So for example, if I'm taking the image using my phone of, let's say, my niece, then if I move forward, then most of them, they are of my niece, and then there might be some duplicates as well. So I don't want them all to be in the same line. I want to shuffle them so that some of them go to testing, some of them go to validation, some of them go to training. Otherwise, all of them will go to training and none of them will be in the testing. So that's not good. So what we will do is we will shuffle it. So how can we shuffle? We will write random dot shuffle, and we will shuffle unique names. That's it. That's how simple this is. And now remember this, it's 507. Actually, let's print the unique names as well. So if we run this now, after the shuffle, then right now it's 507, here it's 307. If I run it again, now it's 506, 83. So it is shuffling randomly. Every time it is shuffling the list, and it goes up and down. So that's the basic idea of shuffling. So once it is shuffled, then we can go ahead and find the number of images for each folder. So first of all, we need the length of data, the total data. So here it will be the length of unique names, and we are going to print that. Print unique names. Let's put an F string, and here we will write unique names, and here we will write total data, or let's say total images is this, and the remaining we can remove the prints just to keep it clean. Do we have any other? Yeah, actually let's remove this as well. Okay, so now if we run this, all we will get is total images. Oh, what is it printing? It should print length data, not unique names. So total images are 20. Okay, so now we need to split it up into the ratio that we need. Okay, so here we are going to add a ratio. So we will write here split ratio equals, and we will make a dictionary for this. So this will be train, and the train value is 0.7. Then we have validation. The validation value is 20, which is 0.2. And then we have the test, and the testing value is 0.1. So that will give you a total of 100. So yeah, that's good. And then we can go down, and here we will multiply our length data to get the length for each one of these. So length of, let's say, train equals length of our data multiplied by the split ratio at train. So that will give us this value, and we need to make sure that this value is not a floating point. It should be a real image count. So that's why we will put it as an integer. So the same way we will do it for validation and training and testing. Validation and test. Let's make it capital val, and here we will write val, and here we will write test. So now what we can do is we can remove this from here, and here we can write. So we can write here that our split is basically length of train, then we have length of test, or let's say val, and then we have length of test. So if we run this now, here you go, the total images are 20 and the split is 14, 4 and 2. I don't like this in the same, so let's put it in a new line. So there you go. So the split is basically 14, 4 and 2. So now it is evenly split, because if you add it up, 14 plus 4 plus 2 is 20. So it means all of the images will be used. But what if we add 21 images? So if I go to all, open it in Explorer, and let's say I go to real, and here I will copy, let's say, any random image with its text file, and I will go and paste it in all. Now we have 42 items. So if I run this now, we have total of 21 images, and it is still using 14, 4 and 2 split. And if I add another one even, let's add Let's go to, I added real. This time, let's add a fake one. Now it's 44. And if I run this, now it's 22. And now it's using 15, 4, and 2. So 15 plus 4 and 2, again, it will give you 21. It will not give you 22. So how can we fix this? Let me remove one of them so that it's easy. And if we run that again, it will be 14, 4, and 2. So now what we need to do is we need to account for the remaining. So here we can write put remaining images in training. So we will take the remaining ones and put them in training. So how can we check that? We can say that if the length of our data is not equal to the length of training plus the length of testing plus the length of validation, then remaining equals length of data minus all of this. And then what we can do is we can say that the length of our data, the length of, training plus equals remaining. So it will add to the training. If you wanted to add to testing or validation, you can just simply change it here. So here, this is before the split, and then let's write it after the split. Okay, so before the split, it is actually after the split, it's 14, 4, and 2. And after we have accounted for the remainder, then it is 15, 4, and 2. So that's the idea. Now all the images will be used. None of them will be neglected. So we can remove this part from here and we can paste this over here so that we get the actual split once it is done. So now that we have the number of images per each folder, now we need to get our main list and split it up into 3 different lists. So we have a list of all the unique names and we will split it up into 3 different lists, and using those lists, then we can copy the files. So first of all, we need to split the list, and the ratio or the values that we want it to split into, we are going to put it in a list. Length to split equals length train. Then we have length validation. Then we have length testing. Okay, now we will use the iSlice this to actually split it for us. That's why we imported it. So we will write here input. Remember, I needs to be capital, otherwise it will give you an error because it is already a name. So input equals ITER, and then we are going to give in the unique names. And then all we have to write is a simple loop. The output is basically, we will convert it into a list, and the output is iSlice of input and element, and then we will write for elements in length to split. So basically it's a loop going through all of these, and then it will split the output. So now what we can do is we can print the let's print the output length of output. So it should be 3. So we should have 3. There you go. We have 3 lists, and if we print the output itself, then we can see it should be 3 lists. So here is the bigger list. Inside that you have this list, and here you can see this is the start of the other list, and then this is the last one for the testing, which has 2 images. So now what we can do is, instead of printing it here, we can print here, because this is the actual split up list that we are getting. So what we can do is we can write here output length of output at 0. So this is the length of the first list, and then this is the length of the second and the third. So I'll write here 1 and then 2. So this will make sure that our split is correct. So 15, 4 and 2. And now we have the individual lists that we want to use, and we can use them to create and to copy our files. Now to copy the files, it's very easy. All you have to do is you have to write that our shell utility dot copy file, and here you have to give in the source and the destination. That's it. So our source, let's say our source is our input folder. So we will get it from the input folder. So we are going to write an f string, f dash input folder path. And once we have that path, then we need the file name. So here we will write the file name. So this file name, we are going to get it from our output list that we have split it up into 3 parts. So here we will need that file name, and then we will write .jpg. Okay, and then the output destination is going to be our output folder path, and then inside that we can have it for testing or training and so on. So here we are going to, for example, write train and then images and then JPG. So that's how we will save it. And then we have to do the same thing for the text file as well. So here we will do for text, copy the text from here and then paste it over here. There you go. So where are we getting this file name from? So what we can do is, first of all, we can create a sequence equals, first of all, we have train, then we have val, and then we have test. So this sequence will allow us to change this with a value. So here, when we are in the loop, because we are going to create a loop, then it will allow us to change this value. Okay, once we have that, then we can say for out in output, we are going to loop through that, and then inside out, this is basically a list of the names. So we will say for name in out, we will do this. Let's write file name. So there you go. So let's copy that and paste here. There you go. So now it will copy the file name, and for the sequence we have to give in here sequence, because we have to loop it 3 times, one for training, one for validation, one for testing. So we'll write here sequence, but the sequence needs to have a value of I. So here we have to give in the value of I. So for the first iteration it will be 0, for the second it will be 1, and so on. So we have to give in here sequence I, and this I, we can get it from here. We can enumerate it. We can write enumerate, and that will give us the value. So now it will go through all of these, copy it from here and paste it over here. So let's run that, and there you go. So here in the images you can see it has copied, but I believe I made a mistake. It copied, yeah, I forgot to change this to labels. So it has to save it in labels. Now you might say, okay, now we have to go and delete everything. No, we don't have to, because it will delete the complete folders and it is going to redo everything. So if we run that again, and now if we go back, you can see now it only has these images, and if we go to labels, it has these labels. So 408 and 539, 408 and 539. So that's it. So, and the best part about this is that right now you can see it's the image of my niece and myself. If I refresh it, if I run it again, next time the images will be different. So now you can see earlier it was with my phone, now it's with the real one. If I run it again, now again you can see it's totally different. So that's how good this is. It will keep refreshing and it will keep updating. So this is good. Now what we have to do is we have to create our data.yml file that will contain all the information of how to run this. So it's very easy. All you have to do is you have to use the text part that we have done earlier in data collection. So here, like we opened up and created a file, the same way we are going to open up and create our file. So here we are going to write, so here we can print split process completed. Then we create the file, and then at the end we will say data.yaml file created. There you go. So that's good. And now what we can do is we can actually create it. So here we are going to give it a name. So output folder, yeah, it will be output folder path. And then it will have the name data.yaml file, data.yaml. And then we have to write in, let's bring it back. And then we have to write in the data YAML. So whatever the data is, so here we can define that data. What exactly do we need? Let me just write this here. Creating data.yaml file. So this is the file, and then what we need. So if you have seen the data.yml file, what it has is a path, and then the path to test, train, and validation, and then the number of classes and the name of the classes. So that's the information that it requires. So what we can do is we can create this here. We can write an f string, and inside that f string we are first of all going to write path, and inside that we are going to give in, let's say, data. So we are going to train it online on our Google Colab. If you wanted to train it on your PC, then you have to write in the complete path, the absolute path of your data.yml file. So, sorry, the folder where it contains all the test, train, and validation. So I will show you how to do that as well. Don't worry. I will show you how to train on offline and online both. So here we are giving this path, and once we given the path, then we have to give in a new line. Once we give in a new line, we have to give in a new line here as well, so that we can move on to the next step. And what we can do is here we are going to write train, and then we will write /train / images, and then we will again write /, and then we are going to copy this. We will paste it here, let's just put it like that. Actually, we have to put it at the end, otherwise or do we? No, we don't need to. I believe it will work without that. Let's try it. So this will be val, and this will be val, and this will be test, and this will be test. So that's good. And then we need another line. So we are going to write a new line, and then we need the number of classes. So number of classes equal, so we have to give in the length of our classes. So here at the top we have to write classes equal, and we have to give in fake, and then real. There you go. Actually, let's put it with a double, because we are already using a single. So let's put a double here. fake and real. Okay, so that's good. And this is the length of that classes. And then we need to write the actual classes. So we have to write names. Names are basically classes. There you go. And here we have to again write a new line. And that's pretty much it. So if we close that, there you go. So this is our data now. If we save this and if we run it, we can see there's a data.yml file. We open it up. Okay, so we have all the spacing. We cannot add the spacing, so we have to remove that. We can press shift and tab and it will go back. Let's run it again, and this time around it's fine. So as you can see, this is our data.yml file and it's generated automatically, so we didn't have to do anything at all. So that's how basically you can create and split your data, and then you can actually create the data.yml file. Now let's go ahead in the next step, look at how can we start the training process. So now that we have our data ready and we also have the data.yml file, then what we can do is we can go ahead and train. Now, if you wanted to train it offline, you can do that too. And if you wanted to train online, you can do that too. We are going to look at offline training first, and then we will look at online. Now, the thing is that right now I have not collected a lot of data, but you have to make sure you collect lots of data. So the data that I used was around 7,000 images. So 3,500 for real and 3,500 for fake. So again, using my mobile phone, using the television, and then taking lots of images of my live webcam and so on. So right now I'm going to use the test data because it will be easy to run and it will be faster. But of course, if you are doing it, you have to do it with the real data. Okay, so once we have this, now what we will do is we will create a script for training. So we will go ahead and create a Python file, and here we will write train. And here, in order to train, it's very simple. All you have to do is you have to import from Ultralytics imports Yolo, and then you have to write model equals Yolo, and then you give in the model that you want to use for training. So here, for example, Yolo version 8, and let's say we are using the Nano version .pt, and then we can simply write model.train, and we have to give in the parameters. So the first parameter is the data location. So the data location is basically the data.yml file. So here we have to give in the path. So where exactly it is in the data set, and then split data and this. So we can just copy, here you can see copy path, and we can copy from content root. So it will be data set, split data, data.yml. And the second parameter is basically your epochs. Epochs equals, let's say we'll put 3 epochs for now because we're just testing it out. So this is the basic idea. Now, if you want to train offline, you have to make some changes to the data.yml file. So I will copy this and paste it, and I will write data2, or let's say offline. So in offline, what you have to do is, first of all, you have to give the absolute path to this data offline YAML file. So we will copy that. So we will right click and copy path and copy absolute path. And here we will write this. And then you have to remove these from here. There you go. And that's it. So the rest remains the same. We can save this and we can write here data offline.yml. And now if we run this, and remember, you do have to install the GPU for your training. So if you remember in the beginning, we learned how to use this. You just have to go ahead and install this and uninstall the previous Torch Vision and Torch Audio, and then install it using this command. If you haven't checked it out, go back and go to the installations and run it for GPU. Otherwise, it will run on CPU and it will be very, very slow. So what you have to do is, now if you run this, you will see that there will be an error. So if we run it, it will first download the Yolo Nano, and then it is saying images not found. The missing path of the, I believe I wrote the path wrong. Oh, I gave the whole path. It is supposed to be till split data. There you go. And then it has all the folders and all that. Yeah, there you go. It found the images. And here they are showing all the parameters that you can use. Patience, batch size, image, save, period, all that. And it's a very long list. You can keep going. Okay, anyways, if you go down, then you will face an error. Okay, it's going down a lot. There you go. So now you can see it. This is the error. It will say an attempt has been made to start a new process, blah, 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 probably means you are not using fork. So what you have to do is you have to use this. That's it. You have to put that in your train, right, like this, and you write main. Basically, you are creating a function. You write def main, and that's it. So you push that in. Oh, you push that in, and that's it. So now if you run this, it should run without any errors. So let's run that. So you can see 0 images are corrupt. It means we have done good annotation. That's good to know. And there you go. So now I'm using a GPU as I think it's finished already. Yeah, it's done with the training. It took 3 epochs and it completed the process, maybe less than a second to actually train, because we have very little data. That's why it trained very quickly and the results will be really bad. So if we go to runs, here you can see all the runs, and in the training 15, that will be the last one. You can see the weights, and this is the best.pt. So this is the one that we are going to use for our testing. And then you have the confusion matrix, you have the curves, you have lots of data to actually check whether it trained well or not. So here you can see these are the labels, and then we have the predictions and all that. Okay, so now we can close this, and once you have this running, and once you have the weights, you can copy the best and you can paste it here somewhere, and then let's paste it in models, for example, and then using our main file, or was it main? No, it was in datasets. It was in testing scripts, and here in the YOLO test, you can copy the code into main, and then you can use that model and to see if it actually works or not. Let's go ahead and do that. So we will go to our YOLO test. We will copy all of that, close this, and into our main, we will copy and paste everything. And in the class names, we are going to remove all of them except for 2. This will be fake, and this will be real. And the model you are getting from models and this, but instead now we will write, we will copy from runs train 15, we will copy from the best.pt, and we are going to go ahead and paste it here. And what I like to do is I like to give it name. So for example, I will write version 1, and this is for the Nano version. So I will write Nano underscore, let's say, version and underscore 1. So this will tell me that this is version 1 of that. And then you can also give in, for example, I did it for 3 epochs. So that's the main idea. And then I can press OK. And here I can write, for example, for Nano underscore version underscore 1 underscore 3 epochs. So if we run this now, let's wait for it to load. There you go. So now nothing is being detected because frankly we didn't actually train it well. It's just 3 epochs. But let me show you what happens if I run it with the training model that I did earlier. So let me copy that in and I will show you how it works. So here I'm going to paste this, and this is basically large underscore version underscore 1, and it trained for 300 epochs. So I'm hoping that it is going to give us some really good results. So let's go ahead and try that out. So let's run that and see if we get fake or real. There you go. I am getting real, and if I put this in, I'm getting fake. That's pretty good. So if I move around, it still says real. If I put this in, it says fake. So that's good. Let me try with another image. There you go. Fake. Now, these are the images that we trained it on. Let's bring in any other image and let's see if that works. So let's say we have this image, and there you go. It says it's a fake. So we will add some coloring and all that. But let's go ahead and first train our model online on our Google Colab, and then we will come back and I will show you how exactly can you change the parameters here and get it up and running. Now, when it comes to online training, we are going to use Google Colab, and I will provide you with the notebook. All you have to do is go to our website and download it from there. So you simply go ahead and drag and drop. So this will upload the file. And once that opens up, we can start. So you can see all these parameters. They will not be there. You can simply press click edit and clear the output. So the first thing we will do is we are going to connect our GPU. So we are it's allocating right now. And if you are able to get A100, that's the best thing. But other than that, you can get T4 or yeah, so I'm getting A100. So that's very lucky because that has 40 GB RAM. The other ones, they have 16 GB or 12 GB. So that's not the best one. But if you have a free version, then you don't have the option. Then you will do as you are given. So and it should work fine as well. It's not a big deal. It will just take a little bit longer. That's it. So once you check which graphic card you have, then you can go ahead and pip install Ultralytics. Now, if you didn't have GPU, you can go to runtime, change runtime type, and over here, make sure it's GPU. Okay, and then the requirements are satisfied. Then we are going to import Yolo. Very simple. And then the next step is optional. If you want to check if it's working or not, it will download the Nano version and it will it will test, and it will save it into this image. So if you want to do that, you can do that. Okay, that's good. And now if we refresh this, we can go to runs and detects and predicts and bus.jpg. And we can see that we have detected. So it's running at the back end. All is good. We are good to go. Okay, so let's remove that. I don't like the outputs. So here now is the main part. So what I like to do is I like to put the data on Google Drive. I don't like to copy and paste here. Now you can do that. It's very simple. Just drag and drop. But this environment is a bit slow. So what I like to do is I like to copy to Google Drive and then bring it here. So, and these two lines will do that for you. So how exactly can we bring? So first of all, you will go to all, sorry, not all, split data. And now we are not using data offline, but all these files, test, train, validation, and data, you will select them and you will right click and send to compressed zip folder. This is very important. You write data.zip. Now, this is very important that you don't create a folder inside a folder. If you open up data.zip, it should have test, train, validation, and data.yml. It should not have another directory. For example, you should not go here and send to compressed zip folder. Don't do that. Make sure it is inside here and select all these and then create the folder. And then you can drag and drop. So what I have already done that. And here you can see I have it in a folder called datasets. So if I go to spoofing, it's in the datasets. In the main directory is my drive. Inside my drive is datasets. Inside datasets is spoofing. And inside that, I have two versions. I'm using version 2. And then inside that, I have data.zip. So whatever folders you have, whatever you have, it's not a big deal. All you have to do is you have to make sure that the name here is correct, the path. So datasets. So this is inside your Google Drive. Datasets, spoofing, version 2. That is what I did. If you have anything else, but you have to put it in a folder. You cannot just put it directly in the drive. You have to put it in a folder. And then all you have to do is press run. So what this line is doing, it will first of all connect and it will ask you permission. Right now I am giving the permission. I will allow it. And then what this will do is it will copy the data.zip from this folder and it will bring it here. And that will be so much faster than dragging and dropping here. So just have a look. So right now it's mounting, it's mounted. Right now it's copying and go. No, go. No, because it's a big file, it's around 500 MBs. It will take a few seconds. It's not that fast. If you had smaller data set, yeah. So it took 38 seconds and it copied it. And if we refresh it, there you go. So you have data.zip. Now it is a zip folder. Now what you can do is you can unzip it. That's it. So here we will press run and it will unzip it into data. And this will take maybe 5-6 seconds. And because there's a lot of images, around 7,000 images. So that's why. So if we refresh it, here is our data. If you open that up, you have test, train, and validation. Inside each one of these, you have images, labels, and all that. You can see this is all my data. This is the actual data that I have collected for training. And this is the data.yml file. So make sure if you didn't do it back then, make sure you do it like this. So for example, this is the example of data.yml file. So if you were training for a ball, you would pretty much do this. And here you can see data, train images and all that. And then this is correct. Now don't run this part. This is not for running. Don't run this part. Okay. And then the last part is the training process. So we will be using the large version so that we get some good results. And we have 300 epochs and the patience is 25. What does the patience mean? Patient means that if, for example, 25 iterations have passed and there is no improvement, then finish the epochs, then terminate the program and finish the epochs, even if you are at 100 or 150. So that's good. And everything looks good. This is the data.yml file link. It is already here, data.yml. So everything is ready and now we can press the run button. So there you go. This dataset I created when I was testing. So I had 11 corrupt files here. You can see the normalization values, they go above 1. So that's why, if you remember, we had to put that criteria that it should not go above 1 in any case. So anyways, it's just a few 11 images here and maybe 6 images here. So that's not a big deal in thousands. So there you go. Now the epochs has started. So it will take, so here it will tell you how much time it will take. If it's a T4, it might take 3 minutes to do one. If it's A100, which I have right now, it might take 1 minute to do one. So 300 will take 300 minutes to finish. So this is running right now. And once it is done running, you can go to runs and detect and train. And then inside that you have weights and you can download the best weight or the last weight. So I recommend the best weight rather than the last weight. So here it's taking 52 seconds. For testing, it is taking 9, 10, 11 seconds. So there you go. And we will let it run. And what I've done is I've already trained it. And this is the whole process. And I've already trained it. And it took, let me show you how much it took. It took, where is it? 4.7 hours to complete. So this is the file that it has created and it has 87 MBs. So if we go to runs, detect and train and then weights. So this is the best.pt. So we will simply go ahead, click here and download, and this will download the file. I've already done that. So here you can see, and the main thing is that the loss should keep decreasing, whether it's box loss, classification loss, DFL loss, all of them should keep decreasing. So here you can see it's 0.09, which is very good for classification loss. So if you check where did it start, so in the beginning, the classification loss was 0.4, 0.46, 0.3. So it went all the way down to 0.09, which is very good. And the box loss as well, you can see it's 0.4 over here, 0.5 over here. And then if you go down, it has reached 0.19 again, which is very good. So hopefully this will give us some excellent results. So once you download it, as we have seen earlier, what you can do is you can bring in your file into this model folder, and from here you can run this. So let's run it one more time, and then we will make a few changes onto it so that the color is visible, and we can write big, like if it's fake or real, so that it's good to look at. Okay, so now it's running, and there you go. It's telling that I am real. It's good to know. And then we have, let's say, another image. There you go. It's fake. And that works fine. So what we can do now is we'll make a few changes, and once we are done, then we will do more testing. So here, for example, what we have to do is we have to create a color. Yeah, so here we are already checking. Are we checking for the confidence? No. So we can check here that if the confidence, did we save it somewhere or not? Yeah, conf is greater than confidence, then only you will do this. So here we will write that our confidence equals 0. Let's say 8. And yeah, this is fine. Now what we will do is we will check that our class name, so this is basically CLS is the index, I believe, and then class names CLS will give you the actual name. So what we can do is we can check if this equals real, and then we are going to write that our color equals 0 BGR, so 255 and 0. We need green color if it's real, else the color should be red. This will be 0 and this will be 255. And what we can do is, not from here, let's go down from here. And what we can do is we are putting the text rect, and we are also putting the rectangle. See, this is the corner rectangle. So let's actually put it only once it's detecting, and this should be before the text. Okay, so this should have the same color. So color for C is basically the corner, and the color for R is the rectangle. So both of them should be color. And the color for put text rect, we can write here that the color R is for the rectangle, should be same. Then the color for the text is white, color for the background is red as well, or the color. So if we run that now, we should have some better results. So here, if I open this up, there you go. So now it's green. And if I bring in fake image, there you go, it says fake. That's excellent. And it's all red. And now here at the top, we can make a little bit of change. Let me push this a little bit up. There you go. So here at the top, let's make a little bit of change because it's not really visible. It's not clear. So what we can do is, first of all, the class name, we want to make it so that it actually is displaying in capital letters. So we'll write here dot upper, and then the confidence value, we will multiply it by 100, and we will make sure it's an integer so that it is looking good. And then we can also add a percentage in front of it so that we know it's percentage. So this is the class name and the percentage. And then what we can do is we can change the scale. Let's put that to 2, and the thickness, let's put that to 4. So it's much bigger than what we are looking at. There you go. Now it's much better. It says real and it's 96% sure. And if I open, let's say, there you go, it's fake, 90% sure. And if we have it like this, there you go, fake 95%. And if I open my own image, there you go, you can see the difference between fake and real. So that is looking pretty good. So as you can see here, it's detecting the fake faces, and there you go, it's detecting properly, it's fake. And if you move to me, there you go, it's real. I go back, there you go, it's fake. So now we have trained our data set, and you can see that with our own data set, it is giving us some really good results. And we didn't actually train it on books and images, but it still detects it as fake. Now, if you wanted to improve it, you can, of course, add your own criteria. And this is the best part, that you can use it with your own data set, and you can take your own images very quickly. So it took me around 20 minutes to collect all these 7,000 images. And then the training part took around 4 hours. And now we have the end result, which is amazing. So 1 day of work, and you will be able to get your own real world application for your model, and it will be catered towards your application. So that's the best part, because sometimes you might have people wearing different stuff, maybe wearing a mask. Now you want to detect real and fake and something other than that. So you can have your own images, your own environment, and train it. So this is the best idea about this project. So this is it for today's video. I hope you have learned something new. If you liked the video, give it a thumbs up. If you loved it, share it with your friends and help spread the knowledge. And I will see you in the next one.